Hello students, in this video lecture we are going to discuss DPP third of NEET Compendium in ionic equilibrium, right. Now first question is, ionic product of water increases if, ionic product of वाटर जो है इंक्रीज़ करेगा अगर हमारे पास टेम्परेचर इंक्रीज़ होता है, राइट। तो आंसर आ जाएगा आयनिक प्रोडक्ट ऑफ वाटर कभी इंक्रीज़ होगा जब हमारे पास टेम्परेचर इंक्रीज़ होगा। देखिए concept regarding the ionic product of water. Ionic product of water is represented by Kw, right, and it is the product of concentration of H positive ion and concentration of OH negative ion, right. And the ionic product of water, it is directly proportional to temperature. If you increase temperature, right, the ionic product of water will increases, right. And the ionic product of water at 25 degrees Celsius is found 10 raised to the power minus 14 molar, right. In case of pure water, concentration of H positive ion is equivalent to concentration of OH negative ion. From this we can write ionic product of water Kw is equivalent to concentration of H positive का whole square, right. From this we can write concentration of H positive under root Kw, right. The value of Kw is 10 raised to minus 14 and its root it will become 10 raised to minus 7 at 25 degrees Celsius, right. So we have to remember these important points regarding the ionic product of water, right. Now question second is, pKa value of weak acid is 5.76 and pKb value of weak base is 5.25. what will be the pH of the salt formed by the two? हमारे पास एक वीक एसिड है और एक वीक बेस है, इनके pKa वैल्यूज़ एंड pKb वैल्यूज़ गिवन हैं, तो हमारे पास pH पूछा गया है जो इन दोनों कंपोनेंट से जो सॉल्ट बनेगा, राइट। तो हमारे पास वीक एसिड है और वीक बेस है, तो इससे जो साल्ट बनेगा वो भी वीक ही होगा, राइट। दोनों कंपोनेंट्स वीक हैं, तो उसका पीएच जो है कैलकुलेट करने के लिए वी हैव द फॉर्मूला दैट इज़ पीएच इक्वल टू हाफ pKw plus pKa minus pKb, right. Now 1/2 is the same here, the value of pKw is 14, right, और pKa का वैल्यू जो है गिवन है 5.76 और pKb का वैल्यू है 5.25, राइट। जब इसे हम मैथमेटिकल सॉल्व करेंगे ये 14.51 आएगा और 2 से डिवाइड करके हमारे पास 7.255 आंसर आ जाएगा यहाँ पे pH वैल्यू, राइट। एक्वा सोल्यूशन हमारे पास जो है पूछा गया है, एक्वा सोल्यूशन सोडियम एसीटेट का CH3CONA विल बी, ये साल्ट है हमारे पास सोडियम एसीटेट, it is a salt of weak acid that is acetic acid and strong base that is sodium hydroxide. तो स्ट्रॉन्ग कंपोनेंट जो है डिसाइड करता है नेचर ऑफ द सोल्यूशन। स्ट्रॉन्ग कंपोनेंट यहाँ पे हमारे पास स्ट्रॉन्ग बेस है सोडियम हाइड्रोक्साइड, तो जो एक्वा सोल्यूशन होगा सोडियम एसीटेट का इट विल बी अल्कालाइन दैट इज़ बेसिक, राइट। तो ये आंसर आ जाएगा हमारे पास अल्कालाइन, ओके। अब हमारे पास जो क्वेश्चन फोर्थ है, 50 ml ऑफ 2 नॉर्मल एसिटिक एसिड गिवन है, Ka का वैल्यू जो है डिसोसिएशन कांस्टेंट ऑफ एसिड 1.8 इंटू 10⁻⁵, इसे मिक्स किया जा रहा है 10 ml ऑफ 1 नॉर्मल सोडियम एसीटेट सोल्यूशन के साथ। तो यहाँ पे अप्रॉक्सीमेट pH कितना होगा हमारे पास, n मतलब नॉर्मलिटी गिवन है, राइट। तो हमारे पास एसिटिक एसिड गिवन है, हमारे पास सोडियम एसीटेट गिवन है, एसिटिक एसिड दिस इज़ फॉर्मूला और नॉर्मलिटी गिवन है 2। तो हम जानते हैं नॉर्मलिटी इक्वल टू मोलैरिटी मल्टीप्लाई बाई n फैक्टर, राइट। और n फैक्टर जो है एसिड के लिए कैसे डिफाइन होता है, n फैक्टर ऑफ एसिड दैट इज़ गिवन एज द नंबर ऑफ H पॉजिटिव आयंस डिनोट गिवन बाई एसिड दैट इज़ द n फैक्टर, राइट। हियर वी विल राइट गिवन H पॉजिटिव आयन गिवन बाई एसिड। तो जो एसिटिक एसिड है इट कैन गिव ओनली 1 H प्लस, राइट, इट्स n फैक्टर इज़ 1। Now normality equivalent to molarity multiplied by n factor, normality is 2, molarity we have to calculate, n factor is 1, from here molarity is 2, right. volume is given 50 milliliter, we convert it into liter, right? We will divide it by 1000, and after calculation we will get 0.05 liter volume, right? In the similar way, here we have this salt of acetic acid, weak acid, and strong base NaOH. Strong base NaOH, it has N factor 1. In the same way, N factor for base is the number of OH negative ions given by the base. So normality is 1, we will use the formula normality equivalent to molarity multiplied by N factor, right? Normality is given 1, molarity we have to calculate, because first of all we will convert normality into molarity, right? Now molarity is 1 here, volume is given 10 milliliter, after converting it into liter we will get 0.01 liter, right? Now concentration, we have the formula number of moles N upon total volume, right? From here number of moles can be calculated by concentration multiplied by volume. If we have to calculate the concentration number of moles of acetic acid, this is concentration, this is volume, right? And concentration formula same here, number of moles, right? For salt, concentration multiplied by volume, right? Now total volume, that is Vt, 0.05 liter plus 0.01 liter, we will get 0.06 liter. This is the total volume. Now we will calculate the concentration of acid, that is number of moles of this particular acid divided by total volume. This is the number of moles, right? Concentration multiplied by volume upon total volume, right? And in the similar way, the concentration of salt will be given by number of moles divided by total volume. This is the number of moles, right? Total volume. Now pH is given by this formula, that is Henderson-Hasselbalch equation, pKa plus log concentration of salt divided by concentration of acid. Now pKa has the formula minus log Ka plus log, this is the concentration of salt here, and this is the concentration of acid. Now after putting the value of Ka given in the question, right, and after solving this we have this ABCD formula, right? It will become A by B into D by C, and this total volume and total volume will get cancelled out. We will get minus, this is log m into n formula, this is log m plus log n, right? And one formula here, log m power n, right? And this will get log m plus log 10 is 1, we will get 5, right? And this is minus here, and this minus plus minus minus, and minus minus will get plus, right? Log, and this on solving will get 1 by 10. I will write 5 first and then minus log, I will consider 1.8 equivalent to 2, and this is log m by n, log m minus log n formula here, right? From 5 in the same way, log 2 value is 0.3, log 1 is 0, and log 10 is 1. On solving we will get 3.7, right? So pH is 3.7 and its approximate answer is 3. Okay, you have to remember these values, that log 2 is 0.3, log 1 is 0, and log 10 is 1, right? Now next question is question 5th. Find the pH of the solution prepared by mixing 25 ml of a 0.5 molar solution of HCl, right? This is the volume of HCl, and this is the molarity, that is concentration of hydrochloric acid. This is the volume 10 ml of sodium hydroxide, and this is molarity 0.5 molar solution, and 15 ml is water, right? So we have HCl and sodium hydroxide, its concentration is given by 0.5 molar and volume is 25 milliliter. On converting it into liter by dividing 1000 we will get 0.025 liter, right? In the similar way, concentration of sodium hydroxide is given in the question and volume is 10 milliliter. On converting it into liter we will get 0.01 liter, right? Now we can calculate the number of moles by the formula concentration multiplied by volume. In the same way here, so what we will get the number of moles here in case of HCl 0.0125, and in case of sodium hydroxide we will get 0.005 moles, right? Now we are looking here that HCl has more number of moles than the base, so HCl will remain in the water. So remaining HCl in water is 0.0125 subtracted by 0.005, we will get 0.0075, right, remaining moles of the HCl. Now total volume of the solution is, that is 25 ml plus 10 ml that and plus 15 ml. After solving this 50 ml we will get 0.05 liter, right? Now the concentration of H positive, that is remaining moles of HCl divided by total volumes, right? For calculating pH we should know the concentration of H positive, right? And concentration of H positive, that is remaining moles of HCl divided by total volume, and this will get 0.15, right? We can write it as 1.5 into 10 raised to minus 1, right? And now the formula of pH is given by minus logarithm of concentration H positive, right? pH is minus log, this is the concentration of H positive, and this will become the formula log m into n. This will become log m plus log n, right? We will consider 1.5 as 2, right, log 2, and this is log m power n, this is n log m. On solving, log 10 is 1, we will get plus minus minus 1, right, and minus minus this will become plus, and minus log 2, and this will become 1 minus log 2, right? This will become 1 minus log 2, log 2 value is 0.3 and log 10 is 1, right? We will get 0.7, so pH is 0.7, required answer. Now question 6th, the pH of simple sodium acetate buffer is given by pH equivalent to pKa plus log concentration salt by acid. The value of Ka is of acetic acid is 1.8 into 10 raised to power minus 5. If concentration of salt is equivalent to concentration of acid and it is given 0.1 molar, the pH of the solution would be, right? We have given the pH formula as Henderson Hasselbalch equation minus log Ka log concentration acid by salt, right? And Ka value is given, we will put here, and salt ki concentration is given 0.1 and acid concentration 0.1, right? This will become 1 total, and this is log m into n log formula, and log this will become log m plus log n, right? We will consider 1.8 as 2, right? And this we will consider as log m power n, this will become n log m, and log 10 is 1, it will become 5, and plus minus minus 5, it will become minus minus plus, and it will become plus 5 minus log 2. Log 2 value is we have log 2 value 0.3, right? So we will write it here 0.3, and on subtracting we will get this value 4.7, so pH is 4.7, right? Now question 8th is the pKa value of weak acid, right, is 4.80, and pKb of weak base, right, and that is 4.78. The pH of aqueous solution of corresponding salt, right, will be, so we will use the direct formula in case of weak acid and weak base. That formula is half pKa value plus pKa value minus pKb value, right? 1 by 2 pKw is 14, right, because we know the value of Kw is 10 raised to minus 14, and this is pKw, right, that is minus log of Kw, right, and this is minus logarithm of 10 raised to minus 14, and it will become log m power n, log m power n, it will become a minus into minus 14 log 10, right, and log 10 is 1, and it will become minus plus, this will become plus, so we will write direct 14 here, okay, in this way. So what is next here, that is, on solving this mathematically we will get 14.02 divided by 2, and 7.01 is required pH here, right? Now question 9th is, at 90 degrees Celsius the pure water has a hydronium ion concentration or H plus concentration, that is 10 raised to minus 6 molar. The value of ionic product of water at this temperature will be, right? Now We know that ionic product of water is the concentration of H positive into concentration of H negative ion, right? For pure water, these concentrations are equal, and it means concentration H positive is this, and at the same time this hydroxide ion concentration is 10 raised to minus 6, right? This is the ionic product of water formula, and H positive 10 raised to minus 6, 10 raised to minus 6. Bases are same, power must be added in case of multiply here, and we will get 10 raised to minus 12 molar, right? Ionic product of water, right, at the same temperature. Okay, now next question is, which of the following solutions will have pH close to 1? These are four options provided to us: 100 ml of m by 10 HCl, 100 ml of m by 10 NaOH. First of all, we will calculate for this HCl and NaOH. This is volume given here, concentration, volume and concentration, right? Total volume 0.2 liter. We will calculate number of moles for HCl, right? And these are the number of moles for NaOH, concentration multiplied by volume. Now concentration of HCl, total volume by total moles by total volume, right? It will become 0.05, and concentration of NaOH, these are moles and total volume, right? 0.2. So solution is neutral because acid as well as base, there are equal number of moles, equal concentration. So solution is neutral and pH is 7. This is not our answer. Now in second case, HCl and NaOH, volume is 55 ml, that is 0.055 liter. Volume is 45 ml, that is 0.045 liter. Concentration is same here in both case. We can calculate the number of moles, right? Number of moles, concentration multiplied by volume, right? Now we can calculate the concentration of acid by this formula, number of moles upon total volume, right? Number of moles by total volume. Now as we are looking here that the concentration of acid is greater than concentration of base, so remaining HCl concentration is by subtracting we will get 0.05. Now concentration of H plus is 0.01. We can write it as 1.0 into 10 raised to power minus 2, right? This is the formula, minus log, this is the value of concentration H plus, right? On putting this value we will get 2 minus log 1, and log 1 is 0, and we will get pH 2. This is not close to 1, so this is not our answer. Now third option is, we have provided HCl and NaOH, volume is given, right? 0.01 liter and 90 ml, that is 0.09 liter. This is the concentration, same in both case. We can calculate number of moles, right? And these are as. Now as we are looking that concentration of sodium hydroxide, that is base, is greater, so remaining NaOH is given as 0.08, right? We can write it as this concentration in this way. Now this is base, so we can calculate POH, right? Minus log concentration OH negative ion, we will get POH value 2.1. Now pH formula is given by 14 minus POH, that is 14 minus 2.1, and now we will calculate it as 14 minus 2, we will get pH value 12. So this is not our answer, right? Now fourth option, this is HCl and this is sodium hydroxide, right? Volume is given, it will become 0.075 liter, 25 ml 0.025 liter, right? On converting, concentration 1.5, concentration 1. Same. Now number of moles in case of HCl, concentration multiplied by volume, and number of moles in case of sodium hydroxide, concentration multiplied by volume, we will get moles, right? Now total volume, on adding these both volumes, we will get 0.1. Now concentration of HCl, right, and moles upon total volume, we will get 0.15, and concentration of NaOH, so total moles divided by total volume, right? And this is 0.05. As we are looking, HCl has more number of moles, so remaining moles of HCl in the solution, that is 0.15 minus 0.05, we will get 0.1. We can write it as 1 into 10 raised to minus 5. Now concentration H plus is given, this pH formula is this, right? On solving we will get log 1 10 power 1, log 1 is 0, right? And log m power n log m, right? This will become 1 log 10, that is pH value 1. So this is our correct answer, option 4th. Okay. Now next question is question 12. What is the pH of 1 molar sodium acetate solution if Ka of acetic acid is 1.8 into 10 to the minus 5 and ionic product of water is 10 to the minus 14, value given here. Now this is the salt of weak acid plus strong base, right? So overall salt is basic, so we will use POH formula, right? And this should be pkb given here, and this is pkb, right? So on applying the formula, right, log kb value is 1.8 into 10 to the minus 5 log same concentration, right? We will consider here for both the salt as well as the base, right, because we have provided the solution. And after solving this log m into n formula, log m plus log n, so this is 0, and we will consider 1.8 as 2, and this is minus 5 log 10, and this is minus 5, minus into minus plus, 5 minus log 2, 5 minus 0.3, and we will get this value as 4.7. Now pH is 14 minus POH, we will get 14 minus 4.7, that is 9.3 is our answer, required answer. Now question 14th is the pH of 0.1 molar formic acid 0.1% dissociated is equal to 4. That means when this 0.1% formic acid gets dissociated, its pH value is 4. What will be the pH of another weak acid which has same concentration 0.1 molar which is 1% dissociated, right? We will write the weak acid here. Suppose we take the acetic acid, right? We will take acetic acid, on dissociation we will get this, right? When time is 0, it has concentration C, it has 0 and 0. When time approaches, it gets X dissociate, it will X form and it will X form. Now we know X is equal to C alpha, we will write C alpha, C minus C alpha, C alpha, C alpha. Now the concentration of H plus is C alpha, and alpha is given to us 1%, right? Alpha is 1%, that is 1 by 100, 0.01, and concentration is given 0.1. We will write here concentration 0.1, alpha is 0.01, and it will become 10 to the minus 3. pH is minus log concentration H plus, right, and this is 10 power minus 3 minus n log m, right, and we will get 3, right? Answer, required answer.